flight. So we have to make sure
Yeah.
there's time for questions, and in exactly an hour, we're going to stop class. Okay, everybody? All right,
All
let's
right.
get going.
All right. Thank you, Dr. Lambert. So my name is Abdulqader, and it's a pleasure to always be back at Atlantic International University, explaining some of the sides of chemical engineering to you all. So today's lecture is actually quite exciting because last week I was talking about the bioeconomy, and there's a lot of questions arising about biodiesel and bioethanol and how can we actually use them in our vehicles, or is it possible or not? So I thought that it would be interesting to talk deeply or give a special lecture to these two special fuels. So let's start with today's presentation. So here's an overview of what we will cover today. So we'll start by understanding what is the biomethanol and biodiesel, and then we'll talk about the production methods, and then we will move on into deeper talk deeply about it, and then we have a quick conclusion and Q&A exercise. So let's start with an introduction. So what are biofuels? So one second. Could you see the slides? I have forgot to double check actually. Were you able to see the slides, Dr. Lambert? Could you confirm with me?
No, I do not see the slides yet.
Okay, all right. So sorry, that's from my side. All right, so let me
Remember, if you're going to be showing a video,
yeah.
to check that little sound box at the bottom.
Yeah. All right. But yeah, I think there's no videos for this one. But okay, let me share again. My bad on that one. So let's go back. All right. Reference the screen. All right. So share. All right. So you can see my screen right now, correct?
Yes, now, yes.
All right. Perfect. So apologies for that one. So let's go and start right away. So what are biofuels? So biofuels are renewable energy sources derived from biological materials. So unlike fossil fuels, which come from the ancient biological matter that's taken millions of years to form, biofuels are produced through a contemporary biological process. So these fuels, uh, they are derived from direct biomass or fuels that we have, or masses that we already have in our Earth. So we're not using fossil fuels to create them. So with that being said, let's talk quickly about the types of biofuels, because there are different types, of course. So there's first generation biofuels. So these are produced from food crops such as corn, sugarcane, and vegetable oils. So while they were the first to be developed and are widely used, they often compete with food supplies and may have sustainability concerns. For example, in some villages where the food crops are important, then it's important to use other types of crops to produce these biofuels. Then we have the second generation biofuels, which are the ones I'm talking about. So these are from non-food biomass like agricultural residues, woody crops, and waste materials. So these biofuels do not compete directly with food production and are considered more sustainable. Then we move on to third generation biofuels. So these are actually made from algae and other microorganisms, even offering greater sustainability. However, these are still undergoing research and are yet to be commercialized in the current state of the world. So with that being said, let's talk about the importance of biofuels and why they are considered important. So as I said, they do not use fossil fuels. So this means that they are renewable and sustainable. So biofuels can be replenished more quickly than fossil fuels, making them a more sustainable option for long-term energy needs. And because of their sustainability, this results in reduced carbon emissions. So we have lower carbon emissions, helping to mitigate the climate change. As Dr. Lambert was saying, the weather is getting hotter and hotter day by day. So this is very important that we find ways to reduce the carbon emissions. Not only that, but the human population is growing day by day, and our energy requirements are increasing. So we need to have energy security. So this helps to actually diversify the energy supply and reduce the dependence on fossil fuels, so that we can secure the energy for the generations moving on. And not only that, but this also brings economic benefits because it creates the production and the use of biofuels create jobs in agriculture, production, and distribution sector. So supporting the local economies and fostering economic growth. So these factors highlight why biofuels like the biodiesel and bioethanol are important. And with that being said, let's talk first about biodiesel. So I'm sure you might have heard of biodiesel. Let's have a quick recap of what biodiesel is. So biodiesel is a biofuel produced from vegetable oil, animal and recycled cooking oils, so animal fats or even animal waste. So this is used mainly in transportation. So this is mainly commonly blended with gasoline. So for example, in the States and in Europe, if you go to your nearest petroleum, if you want to refill the gas, you would see that there's actually biodiesel and bioethanol options blended with the current diesel. So this is an attractive option for transportation. But not only that, it can also be used in industrial power applications, because when you need to generate heat and energy, these biofuels are very handy. So with that being said, let's talk a bit about the characteristics of biodiesel. So biodiesel is essentially a mixture of monoalkyl esters of long chain fatty acids. So in short, they're called FAME. So these esters are derived from the processing of oils and fats, essentially. With that, here are some of the key characteristics of biodiesel. First, it is non-toxic, so it's actually safer to handle and less harmful to the environment compared to conventional diesel. Not only that, it's also biodegradable. So what does that mean? It means that biodiesel breaks down more easily in the environment, reducing its impact if it's spilled. Also, it has fewer pollutants. So when burnt, biodiesel actually produces fewer pollutants compared to the conventional diesel. So this helps to contribute to a cleaner air and reduction in greenhouse gas emissions. So these attributes make biodiesel a compelling alternative to traditional diesel fuel, particularly in efforts to create more sustainable energy systems. With that being said, let's talk now about bioethanol. So bioethanol is another type of biofuel produced through the fermentation of sugars. So this is important to know that we ferment sugars found in crops like corn and sugar cane. So this process transforms from sugars into ethanol, which is the form of alcohol that can be used as fuel. So bioethanol is essentially ethanol, but produced through biological sources, hence the name bioethanol. It is also can be used like biodiesel in transportation blended with gasoline to power vehicles. It can also be used in applications in industrial applications and power sectors. So the use of bioethanol also helps reduce dependence on fossil fuels and contributing to lower greenhouse gas emission, making it a key player in the future of sustainable energy. So we talked about biodiesel. Let's talk about the characteristics of bioethanol. So bioethanol is a clear, colorless liquid that is widely used as a renewable fuel, as we know. So some of the characteristics, like biodiesel, is also non-toxic, so it's safe for use in various applications without posing significant health risks. It is also biodegradable, so it breaks down naturally in the environment, reducing the impact on the ecosystems. And it's also a high octane fuel. So this means that bioethanol has a high octane rating, which makes it an efficient fuel for improving engine performance and reducing knocking in ages. Basically, if you're not aware of what high octane number means, is that if a fuel has a better high octane number, it means that its performance is going to be better in engines. So the higher this octane number is, the better the performance of the fuel. So this shows that bioethanol has good characteristics as a fuel. Now, let's talk about the feedstocks and go into more detail on how we can produce biodiesel and bioethanol. Because these come from biological sources, we have a versatile amount of feedstocks that we can look. So let's take a look at each feedstock. So starting with biodiesel. So biodiesel is produced from vegetable oils or fats. So the virgin vegetable oils include rapeseed, soy, sunflower, palm, mustard, flax, and canvas oils. And there's even a lot that I haven't talked about here. Then we have exhaust vegetable oils. So these are the used cooking oils can be repurposed for biodiesel production. So for example, even the oils that we use cooking in our home, these can be actually after several uses can be used for biodiesel production. Then we have animal fats, so tallow, byproducts from processing animal residues, and omega-3 rich fish oils can also be used. And I also mentioned that we can use algae. So this is a third generation biodiesel. So we can use algae such as spirulina, chlorella, and dunella, which are innovative sources used in the production of what is known as oil-gai, so oil plus algae. So these diverse feedstocks actually highlight the adaptability of biodiesel production to different raw materials, each offering unique benefits in terms of availability, sustainability, and efficiency. And of course, this depends on which country is producing biodiesel. If you have, for example, more palm oil, like if you're talking about countries like Malaysia, Indonesia, then palm oil is an attractive option to create biodiesel with. So let's try to focus now on soybean oil as a key feedstock for biodiesel production. So soybean oil is extracted by cracking soybeans and using a solvent, which is typically hexane. So it's widely used in cooking oil, processed foods, and biodiesel production, especially in the USA. Then we have the global production major crops. So as we mentioned, that it's mainly used in North America, South America, and even Asia. So soybean is an attractive option for biodiesel production. So the leading producers, as you said, the US is the largest producer with 32% of global production, followed by Brazil at 28%. Now let's talk about the oil yield. So the soybean oil yield is relatively low compared to the other oil crops, which is around 0.5 tons in the US and Brazil per hectare and zero point 0.4. So this is relatively lower than other crops like rapeseed, palm oil, and coconut. But because soybean oil has also other agricultural advantages, which is it can fix atmospheric nitrogen. So this means that it requires less nitrogen fertilizer, which is energy intensive and reduces the environmental impact. So this is one of the reasons why actually the US and Brazil are really keen on using soybean oil, other than the availability of it, of course, in those regions. So in Brazil, the soybean cultivation has been linked to deforestation in the Amazon. However, even though there are some advantages, there has been some disadvantage of using soybean oil, which it says that it could be the reason for deforestation in the Amazon. So these are things to take note of when using soybean oil. However, in the US, the use of genetically modified soybeans is common now. So this actually draws a lot of criticism from various groups. Now let's transition to another oil, so rapeseed oil, which is a crucial feedstock for biodiesel, particularly in Europe. So rapeseed oil, also known as canola, is the primary feedstock for European biodiesel, unlike in the US, where soybean is more commonly used, just like we just discussed. So, like soybean oil, rapeseed oil is also edible, but it offers a higher yield of approximately 1 ton per hectare of oil, which is roughly double that than the soybean that we just saw. As for the major producers, these include China, Canada, the Indian subcontinent, and Northern Europe. As for the historical significance of rapeseed oil, it was actually the first vegetable oil used for biodiesel transesterification, which is the process to produce biodiesel, and continues to be the most widely used vegetable oil for biodiesel production. So the most common biodiesel is rapeseed methyl ester, which has a slightly higher energy density and emits lower NOx and CO compared to the biodiesel produced from soybean in the US. As for the environmental considerations, rapeseed oil unfortunately requires significant nitrogen fertilizer, so this leads to a higher energy input and potentially a smaller environmental benefit compared to other biofuels, especially when compared to petroleum diesel. So it's important to know that the biodiesel that you get really depends on the feedstocks, which is why I'm paying a lot of attention to actually describing each feedstock, because the final product that we get is going to be different. So this is a very important note to take note of. Now let's talk about palm oil, which is also another essential feedstock, as I said, for countries like Malaysia and Indonesia. So palm oil is extracted from the food of the African oil palm and is an edible oil. So for example, the Nutella that you eat, this has a lot of palm oil. So it's used in everyday products. So this is a very common oil that we use day by day. In 2006, palm oil became the most widely produced vegetable oil in the world, even surpassing soybean oil. So it accounted for over 25% of all biological oil production, which is 37 million tons produced. So that's a lot of oil. It's also the most productive oil, so it thrives in the tropical region. So the yields can actually reach up to 5 tons per hectare, which is 10 times the per hectare yield of soybean oil. So we can see that palm oil is actually very productive to actually grow. As for the economic significance, palm oil is a significant source of income like in countries like Malaysia, where earnings from palm oil exports exceed those from petroleum products. So we can see a country that's actually making more from palm oil based biodiesel than actual petroleum products. So this is something very nice to see that. Then, as for the cultivation and expansion, so driven by the biofuel requirements from the US and the European Union, the palm oil has led to a dramatic expansion of palm oil cultivation in tropical regions, offering potential for poverty alleviation. So this could be also a way of to combat the difficult economic situations. So palm oil, we see that it's also a very good and viable option, especially if there's abundant resources in the region. Then we move on to jatropha oil. So jatropha is a non-edible native to tropical America, but it can also be found in the subtropical regions of Africa and Asia. So this seed contains around 30 to ranges around from 30 to 50%, making it a viable source for biodiesel. One of the significant advantages of jatropha oil is that it's non-edible, which means that it does not compete with food crops. Additionally, it can be grown on marginal land unsuitable for conventional agriculture. However, there are some challenges with jatropha oil, is that the seeds and leaves are toxic to humans and livestock, which is one big downside to take note of. Moreover, jatropha is currently limited to tropical climates, suggesting that further research is needed to explore its potential in more temperate regions. However, jatropha oil is still a very promising source. Now let's move on to bioethanol. So we've talked about some of the feedstocks of biodiesel, and now we'll shift our focus to bioethanol. So bioethanol is primarily produced from energy crops. So you might be wondering, what are these energy crops? So these include grains like corn, maize, and wheat. It can also be produced from waste products, so the waste straw, the sawdust, and also from grasses. So reed canary grasses, cord grasses, and also trees and plants. So willow trees, just some artichoke. These are examples of some of the trees and plants which can actually be used for bioethanol production. So continuing with the bioethanol feedstocks, we talked about ethanol production being by fermenting sugars. So these are found in the plants like the grains and stems and leaves. This is the key step in actually converting biomass into bioethanol. Almost any plant can be used as feedstock due to their sugar content. So there's a very big versatility in sources for bioethanol production. It also depends on the climate, the landscape, soil, sugar content, and processing ease. So of course, we have a lot of different feedstocks, but we need to see which one is the most appropriate for our production plant, for example. So this results in a variety of ethanol feedstocks and production processes. So this is important that we need to optimize our processes to the feedstock to ensure that we have the best outcome. So for example, Brazil, they use sugarcane, the US uses molasses and corn, and Europe uses wheat and sugar beet. So we can see that every country or every region is using a different type of source. That doesn't mean that that source is the best, but it could mean that it's the best for the technology available in the region. So approximately 3 tons of grains produce 1 ton of ethanol, just to give you an idea of how much plant it takes to produce bioethanol. So we've talked about the feedstocks. Now we will dive into the production methods for biofuels. So here we break down the biodiesel production into 3 main stages. So first, the pretreatment. So this involves the extraction of oil from the feedstock. So the oil can come from various sources like we talked about, so vegetable oil or animal fats, for example. Then in the production stage, this is the core of the biodiesel production process, which is the transesterification reaction. So this chemical process converts the extracted oil into biodiesel by reacting it with an alcohol, usually methanol, in the presence of a catalyst. Then we go to post-treatment, which is after the production. The biodiesel undergoes purification to remove impurities and byproducts. So this step ensures that we have the final product which meets the quality standards of the market and can be efficiently used in engines. So understanding these stages is key to grasping how biodiesel is made and what are the factors that actually influence its quality and efficiency. So let's talk about the oil extraction process. So it involves several key steps, focusing on separating fats and proteins from the vegetable or animal using the biodiesel production. So first step is cleaning. So this is the initial step that ensures that the feedstock, for example, such as seeds, is free from impurities before processing. Then we perform decortication, which is eliminating the protective lignocellulose layer known as the pericap. So this layer does not contain any oil, so its removal helps to enhance the efficiency of the oil extraction process. Then we have heating and conditioning, where we heat the feedstock, increasing the speed of the oil extraction, which forms a water film, further enhancing oil diffusion, making the process more effective. Finally, we have expression, which is the mechanical process where oil is extracting either by applying pressure or chemically by using solvents like hexane, which help to separate the oil from the seeds. All right, so now let's talk about the crux of the biodiesel production, which is the transesterification reaction. So this is a crucial chemical reaction in biodiesel production, which involves converting the fats or oils, which are the triglycerides, into biodiesel and glycerol. So here's how it works. So the triglycerides react with an alcohol. So typically the alcohol uses methanol in the presence of a catalyst such as sodium or potassium hydroxide. So this reaction produces the fatty acid methyl ester, FAME, which are the biodiesel, and a glycerol as a byproduct. So the triglycerides are broken down into their component fatty acid chains when they react with the methanol. So as we say, this results in the production of the FAME and the glycerol as a side product. So here at the bottom, as I show you, these are the chemical equations for the process. So we have triglyceride with the methanol, and we end up with the FAME and the glycerol. All right.
Abdulqader, can I ask a quick
Yes.
question?
Sure.
If somebody has the farm and they're producing some of these feedstocks, how easy is it for them to actually produce biomethanol from their own feedstocks?
Well, I mean, if we this of course depends on the production. If we're talking small scale, that could be quite straightforward in a lab setting. But if you'd like to produce a lot, then of course you would need a production plant, and then this gets very complicated because you know you have to control the reaction on a bigger state. But yeah, if you're talking small scale, it's actually not very hard. You just need to have the right equipment, the correct lab equipment, and proper heating equipment to do so. Yeah.
Okay,
If you go on YouTube, there's a lot of videos actually that make these biodiesel directly from small scale. So this is very interesting to see. Yeah, thank you for your question. All right, so let's move on now and talk more about the reaction. So this is quite relevant to what Dr. Lambert was asking about. So we need to know how the reaction works for if we want to, for example, replicate it. So they're critical to the efficient production of biodiesel. So the temperature is typically conducted close to the boiling point of alcohol, so around 65 degrees Celsius. And the pressure is under low pressure, so around 2 atmospheric pressure. So this is why it's actually can be replicated as the pressure and temperature is not very, very high. And the factors that will affect the reaction, for example, the type of alcohol, because usually we use methanol, but then ethanol can also be used. The molar ratio is important. So we need to have a lot of alcohol to triglyceride ratio. Usually the methanol is in excess. As for the temperature, the reaction temperature must be controlled also for the optimal conversion. Then we also have the residence time, which is the adequate reaction time, which ensures that there's complete conversion. Because if we do not give enough time for the reaction to complete, then we cannot have our product. The feedstock quality, it depends also heavily because it impacts your actual final product. So the fatty acids and water content in the vegetable oils or animal fats will affect the reaction efficiency. So we also have catalysts for this process, and there's a lot of, there's different types of catalysts to be used. So the first type is the alkaline catalyst, which common alkaline catalysts include the alkalides, which is, for example, sodium methoxide or sodium hydroxides, or like carbonates, potassium carbonate. And when we use an alkaline catalyst, the reaction typically occurs around 60 to 70 degrees Celsius under atmospheric pressure with an excess of methanol. So the pros of using alkaline catalysts is that we actually have high yields. So we have greater than 98% in a short time, so only 30 minutes. So this is a relatively good yield in a short time. However, the cons of using this alkaline catalyst is that there could be the formation of soaps. So if the oil actually contain a lot of free fatty acids, usually more than 5%, this will produce a lot of soaps, making it very hard to separate actually your biodiesel products and the byproduct because there's a lot of soap being produced. So we need to take note of this when we use alkaline catalysts. Then we have acid catalysts. So these include sulfuric acid, hydrochloric acid, or other organic sulfonic acids. So the conditions, similar like the alkaline, it requires high alcohol to oil ratio and high catalyst concentrations. The pros of using acid catalyst is that we also have good yields, and it's also effective with free fatty acids. So it's suitable for kitchen oil, for example. However, the issue is that it doesn't take 30 minutes, but actually takes a lot of time. So there's high residence time compared to the alkaline catalysts. For the enzymatic catalyst, so we can actually use enzymatic catalysts like lipase. Uh, these these catalysts will require less temperature than usual, so around 35 to 45%, which is actually a good point. But the time could be 4 to 40 hours. So it actually takes a lot of time where methanol needs to be introduced in steps not to affect the enzyme activity, because if the enzyme is not treated properly, it will die and then you cannot have the process. So it's a more delicate process compared to the alkaline and the acidic one. So the cons, as we said, the pros is that it's a highly specific and clean reaction, and there's mild operating conditions compared to the other ones. However, as we said, it's a very slow reaction. It requires long resistance time and high cost of enzymes. So this is the one thing to take note of using enzymatic catalysts. There's even, so we talked that we commonly is produced using catalysts, but there's also a way where we don't have to use catalysts. So this is less common, but it's a growing field right now where you can produce it directly without any catalyst. So how this works is that the free fatty acid acts as the triglycerides. There's a quick homogeneous reaction. It tolerates higher feed water content compared to the previous ones, and it does not require a catalyst separation step, because usually when we have a catalyst, we need to remove this catalyst from a product. So the pros is that it's a highly specific and clean reaction also, and there's easy separation. As for the cons, is also that the technology is not there yet for the non-catalytic process. I mean, it needs more time to be economic or cost effective, essentially. So we talked about biodiesel production. Now we'll talk about bioethanol production. And here I've made a quick sort of diagram where you can see the main steps in the bioethanol production. So the first step is the pre-treatment, which ensures that the material is ready to be treated. And then we have hydrolysis, where the enzymes or acids are used to convert the complex carbohydrates into simple sugars. Then we have fermentation, which is actually the main step in bioethanol production, where the sugars are fermented by the microorganisms to produce ethanol. Then after we produce ethanol, we need to perform distillation, which is a process which separates our bioethanol product from the fermentation mixture. So typically around 90% ethanol at this point. And then we have even a further purification step, which is dehydration, which is basically removing water from the bioethanol. And this will help us to produce pure bioethanol for the market standards. So let's talk about each step quickly. So in the first step, let's take example of corn, for example. So the corn will be initially dry ground. Then the ground corn is then suspended into water. Then the non-convertible parts of the corn remain in the mixture, and these need to be removed during the final distillation process. Then we have the soluble materials, which are extracted using a hot solution of sulfurous acid. This extraction process takes between 25 to 40 hours. And then the mixture is wet ground to further reduce the particle size. And then the non-soluble solids are separated using a hydrocyclone, which is a big unit operation that helps in separating solids. After that, the water corn mixture is boiled for about an hour to complete the pretreatment process. So this is for around 1 hour. So after the pretreatment, we got into the hydrolysis. So the hydrolysis and fermentation are two crucial steps in the bioethanol production. So hydrolysis, how it works is that it uses enzymes to break down the starch. So it contains enzymes like alpha amylase and beta amylase. This hydrolyzes the starch to maltose, and the temperature of this process is around 50 to 60 degrees, and it takes around 1 hour. After that, we have the fermentation process, where after the hydrolysis, the mixture will be cooled down to below 30 degrees Celsius, and then we add yeast. So yeast is introduced to the mixture, converting the maltose into glucose and then glucose into ethanol. So the fermentation process takes about 2 to 3 days, which is an exothermic reaction, producing ethanol. So these steps are performed and simultaneously in a process called simultaneous and saccharification and fermentation, so SSF in short. After that, we said that the ethanol will be purified and separated in the last two steps, which is the distillation and then the dehydration. So distillation, the purpose is to dilute and concentrate ethanol. So this typically ends up in producing bioethanol for around 90% purity. Then we have dehydration, which is the final step to remove the remaining water, as we said, which help us to produce over 99% pure bioethanol. So this is the final product composition. So dehydration can actually be done by several technologies. So it can be done by molecular sieves, or it can be done by isotopic distillation, or even membrane separations. So these are some of the technologies that can be used to further remove the water from the bioethanol. And these are used in different other processes like in natural gas purification and so on. So here I added a quick process flow diagram of the process basically of bioethanol production. So this will give you a clear idea of how it works. So let's take a look at the feed. So the feed is the raw materials. So like the sugars that are coming from the crops, which are introduced into the fermenter. And this fermenter is basically a vessel where the feed is combined with the nutrients and subjected to fermentation by microorganisms. So this helps convert the sugars into bioethanol and other byproducts. The exhaust gas produced during this process can be used as a fuel as well, which you can see at the top of the fermenter. Then we have the cell separator. So the cell separator, what it does is basically the fermented mixture is passed through it, where the microorganisms are separated from the liquid, which is called the permeate. And this is the liquid containing ethanol, which continues through the process while the water is recycled back into the fermenter to maintain efficiency. So you can see that we repeat it in a sort of a loop where we proceed with the bioethanol, and the remaining cells, we basically recycle them back to the fermenter to ensure that we don't lose any of our raw materials. Then it goes through the distillation. The permeate undergoes distillation to concentrate the ethanol, as we said. So it results in around 90 to 95% ethanol. After that, the ethanol goes through absorption unit for dehydration, essentially, where this helps to remove the water and forming pure bioethanol. So this is just a quick process flow diagram. Of course, this is simpler than what happens in reality, but this is just to give you an idea of how the process looks like. All right, so we talked about biodiesel and biomethanol, but now I'd like to talk about the bigger picture. So the biofuels and the biorefineries, because if you have not heard, that is actually now a term called biorefinery, where the original refineries are so-called greenified to adjust for producing biofuels. So let's talk about biodiesel as a fuel. So as is basically of the physical characteristics. So as you can see from the picture, it's liquid with golden to dark brown color. Density is around 0.88 grams per centimeter cube. So the viscosity is similar to gas oil. It has a high flash point, so it's safer than gas oil. It has negligible zero, so essentially zero sulfur content. It has also higher lubricating properties, so this improves engine duration and performance. The oxygen content as well, it enhances the combustion, reduces the unburned hydrocarbons, but results in a lower calorific value, so that's worth taking note of. And as for the usage, it can be used as pure without requiring engine modification. So biodiesel can actually be used as B100 without needing to blend it. But at the moment, it's typically used as a blend with gas oil up to 25 to 30%. As for bioethanol, we see that there's a recent increase in interest of bioethanol. This is because the increased oil prices and environmental concerns help to boost this interest in biofuel. So the European directive shares that the biofuels need to account for at least 10% of the fuel market by 2020. So this is to show that bioethanols or biodiesel and bioethanol are already in the market right now, since there has been a great interest by different policies. So let's talk about bioethanol as a fuel. So we saw that it's a colorless liquid, as you can see in the picture on the right. It has a pleasant odor. Well, that depends. It contains also oxygen. 35% of the molecular weight is oxygen. And it also enhances combustion, reducing the carbon monoxide and unburned hydrocarbons like the biodiesel. And this decreases the calorific value by 40%. So what are the technical challenges of bioethanol? As we know that there are still some challenges we face. So the pure ethanol or ethanol blends definitely require engine adaptations. So this is one of the issues where some of the engines currently are not suited to handle the blends of high ethanol blends. So this is an issue to take note of. There's also another issue with the volatility and isotopes affecting the gasoline components. There's also separation issues in the presence of water. This makes it lose anti-knock properties. So yeah, these are some of the issues of bioethanol. But nonetheless, we can see that the biofuel consumption worldwide has increased a lot. And this is a picture which shows a forecast until 2030. We can see that over the years, the biofuel is getting more and more recognized and will end up more in the market. And if we look at the biofuels value chain, we can see that these are some of the different feedstocks that can be used. These are the technologies in the middle that can be used to convert them and the product that we get. So we can get actually ethanol, 2G ethanol, pyretic oil, which is the pyrolysis oil, biocrude, syngas. We can get biodiesel, heavy vegetable oil. So these are a lot of products that can come from the biofuels value chain. And if we even talk more, so as you see, we can have bioethanol, which can be bioethanol, pyrolysis oil, biocrude. So all of these products can be used in different using different technologies and producing different products. For example, like heavy vegetable oil, like from palm oil and so on, can be used to actually even produce naphtha, jet, and diesel. And these can be done in the biorefineries, which I was talking about recently. But of course, the technologies for treating them needs to be well integrated into the current refinery systems. So I've been talking about this transition from a petroleum oil refinery to a biorefinery. So how is it done actually? So this is just a quick example of how it can be done. So let's start from the feedstock. So first, the bio oils, which are the raw feedstock, are brought to the feed tank, and this is the initial stage in the biorefinery process where there needs to be pre-treatment. So before the conversion process, the bio oils undergo pre-treatment. So this involves the removal of impurities and solids. As we say that the oils that come usually are dirty, so they need to be clean. Then we have the heavy vegetable oil process, which these oils are converted or are subjected to hydrogenation, where hydrogen is added, and these fatty acids in the oil are basically converted into various fuels. So we can actually produce renewable gasoline, renewable LPG, and renewable diesel fuel. So the diesel that we use right now can actually be also produced from bio oils, and this is how a traditional petroleum refinery can actually transition to a biorefinery. Here we have, so this is, of course, this diagram is slightly complicated, but I just want to show you the bigger picture of, here we have a normal refinery, which have the key components, for example, the topping unit, which is where the components like naphtha, kerosene, and vacuum gas oil are produced. We can use the current refineries to actually produce green products. So to produce the products from bio oil. So if you look at the green blocks, this basically shows how the current petroleum refinery units can be used to produce the biofuels and so on. So maybe in your free time you can go and actually read and see how this diagram works. It's kind of complicated maybe, but yeah, it's always interesting to see how this can work. So with that, let us conclude our talk and see what I've learned so far. So we've learned that biofuels are very important. Why? As we said, because they play a crucial role in reducing greenhouse gas emissions. They provide cleaner alternatives to fossil fuels, contributing to a sustainable energy future. And they also help to mitigate the environmental impacts of transportation energy productions. As we see, a lot of these vehicles in transportation sector can run on biofuels and biofuels blends. So this helps in even securing transportation without added emissions. It also helps promote energy security and economic opportunities in rural areas, as we said. Now let's talk about the future prospects of biodiesel. Of biodiesel and bioethanol. So the advancement in technology and research are improving the production efficiency of these two biofuels. There's also a potential for feedstock diversification, which enhances the viability of biofuels. As we said, there's lots of feedstocks that we can use. So this means that we can always optimize our process further to cater towards our feedstock. There's also a growing demand for renewable energy, which means that this creates opportunities for the industry expanding. With that, let's just move on to a quick exercise to help us refresh our memory, and we can have a quick interaction. And after that, we're going to proceed to the